We can do a very simple example so that you get a feeling numerical idea. I would have an object here has mass m1, and here I have one m2. Let this one have a velocity v1, and this one has a velocity v2. A one-dimensional problem, just as a warm-up. They plow into each other, and they stick together. I put some glue on one, and so they stick together. That's a given. You have to accept that. Let this be the direction of increasing x. And so before the collision, I have a certain amount of momentum. I can do this on a horizontal table, which is frictionless. I can do it on an ice surface, which is nearly frictionless, and I ignore air drag. So this is the situation before. And so the momentum that I have before equals m1 v1. This is my plus direction. I could put vectors over there, but that's really not necessary because it's a one-dimensional problem, plus m2 v2. But if you like that, be my guest. That's the momentum before. Now they stick together. And so when they stick together, their total mass is m1 plus m2. And then their velocity happens to be v prime. We often give a prime to the situation after the collision occurs. And so now I can apply for the first time the conservation of momentum. The momentum before must be the same as the momentum afterwards, because there are no external forces on the system. When they collide, you better believe it that there are internal forces. You better believe that there is glue. And it goes plunk, and they feel those forces, both of them. The momentum of each one individually is changing, but not the momentum of the system as a whole. And so this equals m1 plus m2 v prime. And so if we put in some numbers, suppose m1 equals 1 kilogram, and v1 is 5 meters per second. Let m2 be 2 kilograms, and let v2 be 3 meters per second. Then you see, since they're both in the same direction, momentum here is 5, plus 6 is 11. So this is 11. And this is 1 plus 2 is 3. So that is 3 times v1 prime. And so v1 prime is 11/3 meters per second. So the conservation of momentum tells you what the speed is after the collision. When we deal with collisions, the velocities of the object before the collision are unprimed. You see here v1, and you see here v2. Now the velocities after the collisions, by convention, are primed. You see here a v prime. Now if after the collision, object 1 and object 2 have a different velocity, we would call it v1 prime and v2 prime. Now in this case, we're dealing with an inelastic collision. So m1 and m2 are stuck together. They are merged. So it is sufficient to just call it v prime. You could have called it v1 prime because v1 prime is the same as v2 prime, is the same as v prime. And during the next 4 minutes you will see that a few times do I call it v1 prime. I wish I really hadn't. It would be better if I had just used v prime. That is unique and sufficient.